If I give this dry ice puck a certain start, it moves straight across the table with a speed which is essentially constant because the forces of friction have been made very small. This is just the law of inertia. An object moves with a constant velocity unless an unbalanced force acts on it. Now, will you give it the same start backwards?
I'll try.
If Dr. Hume gives it the same start, it moves back in this direction with the same velocity. Now, we are on a car here that can move and which really is going to move in this direction, and we're going to repeat the experiment. All right, let's go. Now concentrate on watching the puck. Don't let your eye follow us. And I think you'll see that it'll move faster that way and not so fast this way, relative to you and relative to the wall behind.
Upstream motion as viewed from the shore. You are seeing the combined effect of the motion of the boat and the motion of the current. Determine the apparent velocity of the boat. Subtract the velocity of the current. You have left the velocity of the boat as if it were in still water. Repeat the calculations you made for the previous segment. Find the velocity of the boat in still water. Do you get the same results? Here is the boat going across the current. What direction is the boat pointing? What direction is it moving? You are seeing the combined effect of the motion of the boat across the motion of the current. Determine the apparent velocity of the boat. Subtract the velocity of the current. You have left the velocity of the boat as if it were in still water. Here, the boat turns about and returns to the shore. Notice that the boat is pointed slightly upstream in order to travel straight across the river. Why? You are seeing the effect of the motion of the boat against the motion of the current. Determine the apparent velocity of the boat and subtract the velocity of the current to estimate the velocity of the boat as if it were in still water. Compare the throttle settings used on the boat in all the segments of this chapter.